For nearly half a century, the Leopard 2 has stood as one of the world's premier main battle tanks, representing the pinnacle of German engineering excellence and NATO's armored capability. First entering service in 1979, the Leopard 2 quickly established itself as the gold standard against which all other Western tanks were measured, combining firepower, protection, and mobility in a balanced package that proved adaptable across generations of technological advancement. However, the lessons learned from recent conflicts, particularly the war in Ukraine and evolving threats from peer adversaries, have driven Germany to develop its most advanced variant yet, the Leopard 2A8. This latest iteration represents not merely an incremental upgrade but a comprehensive reimagining of what the Leopard 2 must be to survive and dominate on the battlefields of the 2020s and beyond. The Leopard 2A8 program emerged from a sobering reassessment of armored warfare in the wake of Russia's invasion of Ukraine in 2022. German military planners and the defense contractor Krauss-Maffei Wegmann watched as Russian tanks were destroyed in alarming numbers by anti-tank guided missiles, loitering munitions, FPV drones, and top-attack weapons. Even Leopard 2A4 and 2A6 tanks supplied to Ukraine, while generally performing well, demonstrated vulnerabilities that needed addressing. The conflict revealed that modern tanks face threats from every angle and at every range, from shoulder-fired rockets in urban environments to precision artillery strikes guided by drones operating miles away. Simultaneously, the strategic landscape in Europe had fundamentally shifted. Russia's aggression shattered decades of assumptions about the post-Cold War security environment, forcing NATO members to prepare for potential large-scale armored warfare on the European continent. Germany, as Europe's largest economy and a central player in NATO, recognized its responsibility to field a tank capable of serving as the backbone of European armored forces. The Leopard 2A8 program thus carried both tactical and strategic imperatives: create a tank that could survive and prevail in high-intensity combat while serving as a symbol of European defensive capability and technological prowess. The development of the Leopard 2A8 also occurred within a unique context in Leopard 2 evolution. The Leopard 2A7 and 2A7V variants, which preceded the A8, had already incorporated significant improvements including enhanced mine protection, improved armor packages, and better urban warfare capabilities. However, these variants were designed before the full implications of drone warfare, networked combat, and the proliferation of advanced anti-tank weapons became apparent. The A8 needed to go further, incorporating lessons that were being learned in real time from ongoing conflicts. Comprehensive protection. The most visible and significant change in the Leopard 2A8 is its revolutionary approach to protection. Previous Leopard 2 variants followed traditional tank design philosophy, emphasizing frontal armor while accepting that the sides, rear, and top were more vulnerable. The A8 abandons this concept in favor of what German engineers call 360-degree survivability, recognizing that modern threats can come from any direction and any elevation. The frontal armor receives substantial upgrades, incorporating the latest generation of composite armor packages that integrate advanced ceramics, new steel alloys, and specialized materials designed to defeat both kinetic energy penetrators and shape-charge warheads. The exact composition remains classified, but the armor is reportedly capable of withstanding hits from the most advanced tank rounds currently in service. The turret front armor is modular, allowing for field replacement of damaged sections and future upgrades as new threats emerge. However, the truly revolutionary aspect of the A8's protection is the comprehensive side and rear armor. The tank features extensive add-on armor packages covering the hull sides and rear, protecting against medium-caliber autocannon fire, rocket-propelled grenades, and anti-tank guided missiles. These packages use a combination of composite armor, explosive reactive armor, and slat armor designed to prematurely detonate warheads or disrupt them before they can penetrate the hull. The lower hull receives enhanced mine protection, incorporating a V-shaped hull design in critical areas to deflect blast energy away from the crew compartment. The top armor receives particular attention, addressing one of the most critical vulnerabilities exposed in Ukraine. The A8 features reinforced roof armor on both the hull and turret, designed to defeat artillery-delivered submunitions, top-attack missiles, and loitering munitions. While maintaining the tank's relatively low profile, the enhanced roof protection significantly improves survivability against overhead threats. Perhaps the most significant protective innovation is the integration of a next-generation active protection system. The Leopard 2A8 incorporates an advanced APS that uses multiple sensors including millimeter-wave radar, infrared cameras, and laser warning receivers to detect incoming threats at distances of up to several hundred meters. Upon detection, the system has mere milliseconds to classify the threat, calculate an intercept solution, and deploy countermeasures. The hard kill component fires small explosive projectiles that detonate near the incoming threat, destroying or deflecting it before impact. The system is effective against anti-tank guided missiles, rocket-propelled grenades, and even some kinetic energy rounds at close range. The soft kill component deploys multispectral smoke, chaff, and active jamming to confuse or disable the guidance systems of incoming weapons. The APS is fully integrated with the tank's fire control system, automatically slewing the turret toward detected threats. One of the most debated aspects of the Leopard 2A8 development was whether to upgrade the main armament. The Leopard 2 has used variants of the Reinvented 120mm smoothbore gun since its inception, and this weapon has proven highly effective for over 4 decades. However, the emergence of heavily armored tanks like the Russian T-14 Armata and Chinese Type 99A raised questions about whether the 120mm gun would remain adequate for future conflicts. The Leopard 2A8, at least in its initial configuration, retains the 120mm L55A1 gun, an improved version of the L55 gun introduced on the Leopard 2A6. This decision reflects a pragmatic assessment that current 120mm ammunition, particularly the latest generation of armor-piercing rounds, remains capable of defeating any known armor at typical combat ranges. The L55A1 features improved barrel construction, better thermal management, and enhanced accuracy. If you're finding this deep dive into modern armor fascinating, please hit that like button and subscribe for more detailed military analysis. However, the A8 is explicitly designed to accept the new Reinvented 130mm smoothbore gun if future upgrades prove necessary. The turret ring, recoil systems, and ammunition storage have been engineered to accommodate the larger weapon with minimal modification. This future-proofing ensures that the A8 can receive a firepower upgrade if emerging threats require it. The fire control system receives comprehensive upgrades that may be even more significant than any potential gun change. The A8 features a new generation fire control computer incorporating artificial intelligence and advanced target recognition algorithms. The system can automatically detect, classify, and prioritize multiple targets, presenting the gunner with optimal engagement solutions in fractions of a second. The commander's independent thermal viewer receives significant improvements, with higher resolution and better target identification at extended ranges. Both the gunner and commander stations feature new digital displays with larger screens and more intuitive interfaces. The ballistic computer accounts for an expanded range of variables including crosswinds, temperature, barrel wear, and ammunition temperature. The result is first-round hit probability exceeding 90% at ranges beyond 2 km under most conditions. The ammunition storage system has been redesigned for both safety and efficiency. All main gun rounds are now stored in armored compartments with blowout panels that vent explosions away from the crew if the ammunition is hit. The ammunition types available include the latest DM53A1 and DM73 armor-piercing rounds, programmable high-explosive rounds capable of airburst detonation, and training rounds. The tank carries 42 main gun rounds. Mobility and power plant. The comprehensive armor improvements and additional systems inevitably added weight to the Leopard 2A8, which now tips the scales at approximately 66 to 68 tons in combat configuration, compared to around 63 tons for the 2A7V. This weight increase posed challenges for maintaining the mobility that has always been a Leopard 2 hallmark. The Leopard 2A8 uses an upgraded version of the MTU MB873KA501 diesel engine, now producing approximately 1,600 horsepower, an increase from the 1,500 horsepower of earlier variants. This power increase maintains an acceptable power-to-weight ratio of approximately 23 to 24 horsepower per ton. The engine features improved fuel efficiency and reduced maintenance requirements, with extended service intervals that reduce the logistical burden. The transmission receives updates to handle the increased power and weight, with improved gear ratios optimized for the tank's new weight distribution. The Leopard 2A8 maintains a maximum road speed of approximately 68 km per hour, impressive for a tank of this weight. The operational range remains around 450 km on internal fuel. The suspension system incorporates advanced torsion bars with improved damping characteristics, providing better crew comfort and allowing the tank to maintain higher speeds over rough terrain without sacrificing accuracy or mechanical reliability. Perhaps the most transformative aspect of the Leopard 2A8, though less visible than armor or firepower improvements, is its role as a fully networked combat platform. The tank incorporates the latest generation of NATO digital battlefield management systems, allowing it to share real-time data with other friendly units across all domains. The tank's communication suite includes multiple encrypted digital radios, satellite communication capabilities, and data link systems that allow seamless information sharing. The crew can receive targeting data from reconnaissance drones, artillery observation posts, or other tanks, engaging targets beyond their line of sight. Conversely, the Leopard 2A8's own sensors contribute to the larger tactical picture. The commander's station features a large touchscreen display that presents a comprehensive tactical picture, showing the locations of friendly units, known enemy positions, detected threats, and mission objectives. The system integrates with the active protection system, fire control system, and communications network to provide the commander with unprecedented situational awareness. The tank incorporates systems for controlling and coordinating with unmanned aerial vehicles. The crew can launch, control, and recover small reconnaissance drones directly from the tank, providing aerial surveillance without requiring support from other units. These drones extend the tank's effective observation range by several kilometers. Urban warfare and infantry cooperation. The conflicts in Ukraine, Syria, and other recent wars emphasize the importance of urban warfare capabilities. The Leopard 2A8 incorporates numerous features specifically designed for operations in cities and close terrain. The tank features an array of cameras providing 360-degree awareness of the immediate surroundings, critical for detecting infantry threats at close range. A remote-controlled weapon station can be mounted on the turret roof, allowing the crew to engage infantry and soft targets without exposing themselves. This system can mount various weapons and is operated from within the protected crew compartment using the camera and fire control systems. The RCWS significantly enhances the tank's ability to suppress infantry in urban environments while minimizing crew vulnerability. The tank features improved communication systems for working with infantry, including external telephone systems that allow friendly infantry to communicate with the crew without the tankers needing to open hatches. Additional armor packages specifically designed for urban operations can be fitted, including slat armor on the rear and sides to protect against close-range rocket attacks. The Leopard 2A8 represents a significant leap in capability, but also introduces new challenges for crews and maintenance personnel. The complexity of the systems, particularly the active protection system, network communications, and advanced fire control, requires extensive training. German tankers transitioning from earlier Leopard 2 variants undergo months of additional training to fully exploit the A8's capabilities. The maintenance burden has increased substantially compared to earlier variants. The active protection system requires specialized maintenance and regular testing. The advanced electronics and sensors need calibration and software updates. The modular armor packages require specialized equipment and trained personnel. These factors increase the logistical footprint required to support Leopard 2A8 units. The cost per unit is significantly higher than previous variants, with estimates suggesting each Leopard 2A8 costs approximately 50 to 60% more than a 2A7V. This cost increase raises questions about procurement quantities. Germany plans to upgrade and procure Leopard 2A8 tanks in substantial numbers, but smaller NATO members may need to settle for upgrading only a portion of their fleets. The Leopard 2A8 carries significance beyond its technical specifications. As the most advanced European-designed main battle tank, it represents European technological capability and defense industrial capacity. The tank serves as a potential export platform that could standardize NATO armored forces around a common design. Multiple NATO members already operate various Leopard 2 variants, and the A8 provides an upgrade path that maintains commonality in training, logistics, and tactics. If you're enjoying this comprehensive analysis, don't forget to like and subscribe for more cutting-edge military technology content. The Leopard 2A8 is designed to remain relevant for decades through continued evolution. The modular architecture allows for incremental upgrades as new technologies mature. Future enhancements might include the 130mm gun, more advanced active protection systems, improved power generation 4. The Leopard 2A8 ultimately represents the evolution of a proven design to meet emerging threats while maintaining the fundamental balance of firepower, protection, and mobility that has characterized successful tank design since World War II. It demonstrates that evolutionary development of mature platforms can produce capability comparable to or exceeding revolutionary new designs at lower risk and cost. Whether the A8 proves to be the final major evolution of the Leopard 2 design or merely another step in its ongoing development will depend on how warfare continues to evolve and what threats emerge in the coming decades. What is certain is that the Leopard 2A8 represents the current state-of-the-art in European armored warfare and will shape how NATO fights its armored battles for at least the next 2 decades.